Okay. Um, welcome back everyone. So in the previous two episodes of this series, we investigated this quite okay image format. In particular, we read through the specification, we created a couple of examples, and then we actually looked at the underlying hex of a number of these examples. So for example, for this particular image file, we went through this and we looked at all of these underlying bytes and kind of figured out how exactly the specification was breaking up the image into these chunks. Now having done this, I'm kind of confident with the specification, at least enough to write a decoder, and so that's what I want to be doing today. So when we kind of started this, we wrote something that will pass at least the header of this. And so now it's actually time to write the rest of the decoder that's going to break everything up into chunks. So yeah, hopefully this won't take like more than 5 hours. It will only take a couple, but we'll see. I wanna do a couple of hours now, and then I'm going to a board games event 4 hours from now, so I might have to split this kind of stream into two today. But I want to get this done by the end of the day. That is the main point. Okay. So let's start writing something for this. So we could say function. Okay. Before we do this, I feel like I'm somewhat getting used to the allocator system in Zig and how it works. Like I understand the concept of allocators clearly, but preferably since this is happening in a game, what I want to happen is that at compile time, we still run this header stuff, and then make like a specific A times B array of pixels, for which at runtime the decoding is going to happen and load stuff into. So I want to just at least get that functionality working in now, so that at comp time we do create a variable whose dimensions are going to need to be determined at comp time, and whose dimensions are going to be the image width and the image height. So let's first actually move all of this code into some comp time variable. So why don't we do like comp time header parser, and for this we only going to need something of whatever this type is. So let's see, this should just be like a const for this like embedded QI file. I suppose we can actually just take a pointer to it. And what do we want to take? We want to bring back a something of type QI header. And then we should hopefully be able to copy all of this and then just return it. This said, I'm still getting used to exactly what the correct string fixed array things to enter, so this might take a couple of minutes to deal with. Okay, yeah, so we have our raw image here, which is the test image, and then we simply want to compare something, but actually in the parsing, before we return anything, we should still check that the magic byte's actually correct. If we're doing this at comp time though, I feel like this might give us an error. But if it does, this is just 4 bytes we're comparing. We can manually just check each of those 4 bytes to match the QOIF characters here. But yeah, otherwise, I guess this can go. So then we want to just say that, let's say QO test, test image header. We want this to be what, comp time header parser. We can move it outside. We can move this into the global scope. Let's move it above. We want this to just be thing generated for the test image, and then let's kind of print that out. So we just want to say that the header here is going to be the test image header. Okay. So we need to do zig build, just zig run i.z. Okay, 16 looks like I forgot something. Okay. Unused function parameter, embedded QOI file. Yes, this would be correct. So yeah, this raw image here is just this. Okay, expected this, found this. Okay, so we need to like convert this fixed type to this fixed array to this slice. I think we can do it just with this syntax, possibly. Oh, not this syntax. This one? Nope. What are we gonna do? We can look up the documentation for slices. But yeah, at least if I was programming in Odin for this kind of thing, I would just have to create a different slice. Oh, why was I adjusting this one here? It's this one here I need to adjust. Do we just want to say from this to the length of it? This one? Oh wait, the 0 here is denoting a null terminated thing. Okay, I'm being really silly. So actually, I think what we want to do here then is just indicate that we're passing in something that's null terminated. Still, we need to say, don't interpret this as just like 51, just interpret it as a slice. Okay, so maybe here we do actually slice it there. No. Oh, hey, two-step. Yeah, thank you again for the help. So just accept a array of constant U8. So like this. Okay, brilliant, fantastic. I guess let me ask a question then. Like, why? It's like if this is like now terminated, why was I getting these compiler errors before of something needed to be terminated with a null byte when, yeah, in some of the errors when this kind of just works without one. But yeah, great. Okay, so now we know for this specific image the width and the height. So let's try. Actually, okay. Instead of using this example QOI, which is this one here, let's test it with one of the ones which we've examined the hex of before. So in particular, let's see. Let's try and do it for just one of the like this one here, for instance. Bx dot what does this one look like again? This kind of one here. Okay. Copy this. Okay. So yeah, two-step says the error was because you made the type a pointer to a slice instead of a slice. Okay, that makes complete sense. Great, thank you. Okay. Yeah, so let's bring up our specification again, and okay, so now we've actually passed this in. We can just select the image width and the image height and make an array of pixels with this. So let's first make a data type for this. So we can just say a pixel is going to equal a fixed array of U8, and then once we've done the it will be better to move this down. Once we've done the parsing into this, let's just say that the test image pixels is now going to be the test is going to be a kind of double fixed array where the first argument here should be the number of rows, so that is the height. So you want test image header dot image height, and then over here we kind of want the same, the test image header and then the image width of the type pixel. And now we need to write the procedure that will do the decoding and fill this up in the way we want. Okay. So let's see. And we want to be able to call this at many stages during runtime. So why don't we call this QOI QOI to pixels, and then we should accept a similarly we just want to accept the embedded QOI file that is not a pointer to a slice, but just the slice itself. And then maybe on this iteration we actually just make it work on this one, but hang on, it would be good to declare this in such a way that it returns the appropriate thing. Okay. So in that case, let's then just when we call this, we're going to pass in this thing as a pointer for it to fill up. This is going to have variable type though, so we should pass in these arguments at comp time. Oh, this is getting a bit nasty. Actually, maybe it's not too bad. Why don't we just say? Actually, it will be really useful to know all of these things because this is going to be necessary when we're actually filling out this array. Okay, so why don't we say the image width is, I guess, U32. The image height is a U32, and then we want to accept a pointer to the pixel array. The pixel array is going to be a pointer to the eye width, the eye height, the eye width, and then just the pixels. Okay, so then why don't we, so with all of the decoding that we did, we needed to start with, there's like this running current pixel that gets updated and influences like some of the next operations. We then have an array of like the last 64 hashed previously in 6 pixels that also gets indexed a couple of times. So we need to implement both of these kind of things. So you can see that the current pixel is just equal to 0, 0, 0, 0. And I should annotate in the specification where this comes from. So you can say I'll do it up here. Per the specification, the decoder start with this as the and then let's set up this array. So we want to see like previously seen pixels is equal to just an array, fixed array of this. I want these to be 0 initialized though. In Odin, everything by default is 0 initialized. I'm actually not sure what the convention is in Zig. Will we need to do something like this? Yeah, two-step. If you know, please let me know. So we can say like question, do we need to 0 init this? Okay. In any case, even if it isn't 0 initialized, the only value we actually need to set is the very first one, because the only time this is going to get indexed without previously being updated is if a empty pixel is seen, and in that case, the hash of the 0 pixel is itself 0, and then this is going to look up the 0 index. So let's just set the previously seen pixels to so that. Okay. And then I think before we go a bit further, let's also just write in a kind of simple hash function for this index position. Okay, in Odin you can write functions within functions. not exactly sure what the convention is in Zig. Let's just move it. What's happening, Emacs? Let's just move it out of the function just in case something weird happens. So we want to say pixel hash, which is going to take in a pixel and return a number that's just going to be between 0 and 64. 64 is 6 bits, but I feel like having something in U6 is absurd, so we'll just return this as that. Okay, and then, okay, this is like a really simple, this is as simple as it gets in terms of formula. So we just want to return, oh, hang on. When we're doing this hash, okay, when we did the calculations for this last time, I was just treating each of these U8s as just some usual integer that was like unbounded. I don't think we're going to need to convert each of these to some larger bit integer, simply because we're doing stuff with modular arithmetic. And so if we're taking the remainder of all of this by 64, that's the same as taking each individual term, like remainder by 64, adding it up and doing it again. And that's the same as taking each individual term in the sum, mod 64, multiplying everything together. This said, I feel like there'll be some overflow operation. There will often be overflows, and we need to account for that. So we need to tell Zig, hey, when we're multiplying this number by 3, kind of do it mod U38 and like mod U8. Okay, this was like non-standard functionality, so let's look up what to do. Documentation for 11. Yeah, so we wanted, okay, actually, let me just write the formula, and if it compiles, it's fine. We can run some tests, but I would be surprised if Zig allows me to get away with this. So why don't we just say the compiler should optimize the following lines out. Let's literally just say the red value is the first pixel, the green is the pixel, we want the blue and then the A, and then we just want to return, can I even copy this? Hopefully I can. Okay, we just want to return this. Okay, let's just see if this is okay immediately. So let's kind of print this out. So let's just say test pixel hash is going to be the pixel hash of let's do that. We'll do something that's easy to calculate. So like 1, 1, 1, and 1. And then let's just let's print that here. Test pixel hash, and we're just testing where it's just going to be a number. Okay. Zig run for I. Okay, so TSF is saying multiplication and then the mod should actually be fine. What did I do here that was silly? Oh, I just meant to say this. That I think. Oh. file not found. Oh, this makes sense because this file is actually in QI tests. Okay. Okay, yeah, so it's saying the hash here is 26. Let's see, 3 plus 5 plus 7 is 15, plus 11 is 26. Great. Let's just, okay, I haven't actually used like the testing library features of Zig. I don't want to do that immediately now, but this would still be, if I knew how to do that, we would turn this into a test. So we can figure this out later. Turn the following into a Zig test. Okay, but let's just do another test. So now let's do a test that actually does that utilizes the wraparound. So say like 3 times 100 is going to be, should wrap around to 300 minus 256, which is what, 44. So let's try doing that one. And so this should now hash to 44. Oops, I did something silly. Oh, okay, maybe this something silly is the like, yeah, we are getting an integer overflow here. Okay. So let's do two-step suggestion then of changing the multiplication to multiplication this. Wait, if this is the right thing to do. Okay, will this fix it? Great, okay. And brilliant, we get back 44, which is what we want. Okay, oops. Okay. So we should, let me just annotate this. Using only will result in a compiler, well, in a runtime error. Which was this? Okay, more like a runtime panic. To avoid this, we use instead. Okay. Okay, and since this is the first time I'm using this operation, let me look it up and see what else there is to it. So, I'll zoom in. So yeah, wrapping multiplication. Guaranteed to have two's complement wrapping behavior. I guess since we're dealing with unsigned integers, we don't need to think about this. Okay, but good to know that's what happens in the signed case. Invokes peer type resolution for the operands. See also mul with overflow. Okay. Let's see what this mul with overflow is. Performs A times B and returns the tuple, the result, and possible overflow bit. Okay, interesting to know this is like explicitly how to actually get the overflow bit. And what's this peer type resolution for the operands? Peer type resolution occurs in these places. Switch expressions if This kind of type of resolution chooses a type that all p types can coerce to. Here are some examples. So p result int widening. Oh, okay. So it's interesting that you can do this in Zig then. In Odin, this would be a compile error. You would have to convert either the A to an I16 or the B to an I8. Okay, so if you're adding like different types in Zig, you can like move them up to the largest type if need be. Okay. Okay, so then how would that apply in this case? So this would kind of say then, if you're doing this multiplication with like a U8 and maybe this number here is a U32, I mean, maybe these 3s and 5s are U8s and some U8 variable, and this is U32, then presumably this would convert to like a U32. Okay. Okay, this is good to know. Okay. So yeah, so this one here, we if we're turning the following into tests, I should probably say what the test results are. So for this one, we expect 44, which we got, and then for this one here, we expected I forgot. I already forgot. It was just 3 plus 5 plus 7, which is 15, plus the 11, which is the 26. Okay, so now let's go back to, okay, let's actually just save everything. Use of declared identifier. Okay, this is all working. So I'm going to do git add qi.zig, and let's just say started writing decoder, implemented pixel hash. Okay. So yeah, 2 steps suggest test colon quotation marks test name is how we implement this as a test. Oh, okay. Okay, a suggestion. So we say test name. Standard.testing expect equal as U8, say like 69. Okay. Yeah. If there's more time, if we finish this, I'll come back to this and we'll do this. But back to the decoder. Okay, we've done this. We've initialized the part that needs to be 0 initialized. So now we do. So now we just start reading what the chunks of these bytes are. So we're going to have some loop. And we're going to need to examine the first two bits of each byte. And I'm not sure if I need to consider. Ooh. Okay. Luckily, I was going to say like little endian or endian, whatever. But presumably, we have to deal with like the 6th and the 7th bit of a byte. Hopefully this is in like the same order that it would appear. And then we need to distinguish between all of these types. So it would be useful just to have like an enum with these types, but also make it a bit more readable. So why don't we say struct enum, make this a UA, and we should call this something. We should call this QI QI ops. So we want QI RGB QI op RGBA, then index diff luma run, yep. Okay, and then we're going to have to determine the byte based on these. Okay, oh, it's okay if you forgot like an extra bracket after this part to stack. We'll fix it when we come to it in a couple hours. Okay, yeah, so, okay, we also, let's maintain our own, we need to maintain a position of where we are in the QI file. So we can say current byte index. And because this is a really good file format, this is going to be fixed in each time. So the size of this header is 14 from memory. We have, yeah, the 4 here, plus the 8 bytes of this, which is 12, 13, and then kind of the 14. So the first byte we need to read is the 14th. So then we can just say, we can now have a loop. So we could say, we also need to keep track of the current pixel index we're actually at. And we're moving left to right, top to bottom, and we start at 0. So we can say that while the current pixel index is not equal to while it's less than the final pixel, like the height, the width times the height. We want to read what these things are. So we want to say current byte is going to equal the embedded QI file, but now the current byte index. Okay, so Github says, yeah, individual bytes aren't affected by endianness, only multiple bytes. Oh, great. Okay. Clearly you can tell I'm I'm an expert with like endianness. I've rarely had to deal with it, and so it's good. It's good that Zig is forcing me to think about this. And yeah, in Zig you usually don't need to prefix each enum variant, i.e. QIO XX. Just use XXX. Okay, yeah, sure. Yeah, I guess I was just using this because it kind of has this, it's easy to refer to the documentation in this way, but we can even just indicate that with a comment. So why don't we say here, yeah, in the enum below, ops, the op called like x, y, z refers to q or I op x, y, z in the specification. Okay. So yeah, let's get rid of this then. Oops, I was silly. We want to replace this with this. Okay. Yeah, and this is so much easier to read. Good code system. Okay, and then I need to turn it down. I feel okay. Okay, so now we've done this. So now we have the current byte. We now need to examine the first two, the 6th and 7th bit. So let's just say okay. So these first two bits, there's only going to be 4 options, right? It's going to either be this one, this, or this. And if it's the 3 case, we need to alternate between these. We could possibly arrange these in such an order that the very first one corresponds to 0, 0, the next one corresponds to 0, 1, etc. I feel like this, while I and everyone watching this might know that's what we're doing, I kind of might forget it in the future, and it wouldn't be that great. And so I think it's actually best just to compute the first 2 bits explicitly, and then have a switch statement and say, if the first 2 bits is this, do that, then do this, then do this, instead of just looking something up as an index. Okay, so we want to say first, okay, or like bits 6, 7 is equal to, this will still have to be a U8, but we'll make it the current byte once we AND it with what's the byte gonna have to be? The bytes. This is an opportunity for us to use the binary notation in Zig. Okay, I think that's how it works. Let me just check. If I do like 0B, yeah, great. And then once we have that, we want to bit shift it to the right by 6. And now we want to switch on this. So now I want to switch on bit 6, 7. How do switch statements work again? I always forget. I will remember eventually. Okay, so we want to say switch on the variable, and then we just do the cases. Okay, so we have the case of 0, then we have the case of 1, This is a bit vague. What I think it would be better just to write it like this, and then this. If it's this case where the bits are 3, we're going to have to do another comparison where we see if the next bits are equal to this or this. So part of me thinks, why not just compute this earlier as well? So now I want to just say bits 0, 1, 2, 3, 4, 5. So we have the current byte, and now we're ANDing it with this, and that's what we need to do. Okay, so in the first case, when we get 0, 0, we have an index. So let's keep track of what this thing is. So we should also say like current QI op, and to begin with, let's set this to be QI ops RGB. Oh, okay. Two-step says 6 is enough. The AND isn't necessary here. Oh, that's totally true. Thanks for the correction. And then yeah, like I guess it's good to know the Z compiler is smart enough to do that. Because yeah, like sometimes since this is just running on a 64-bit machine, like there was one time long ago where I had some like bug where I did like something like this, and then like some like high bit was like transferred over, and so I just got into the habit of always just saying end it with something to kill all of the high bits and then move it down. But it's good to know you can do this safely in Z. Okay, yeah, so if it's 0, okay. So why don't we actually just say the current QI op is going to be equal to the result of this switch, and maybe it's actually better just to say this is a QI op, and it's undefined at this point. Okay, and then we're setting this to index. If it's 0, 1, we're setting it to diff. If it's 2, we're setting it to luma. And if it is 1, 1, we need to do another switch. We need to switch on the bits 0, 1, 2, 3, 4, 5. And then in the case that we get 0B 1, 1, if I'm specifying stuff in, I should just be able to specify 6 bits here, like I specified 2 here. So if it's 6 ones, then it's going to be, let's do it in the same order. If it's 5 ones, then a 0, this is RGB. If it's 6 ones, then it's RGBA, and otherwise it's going to be a runtime. And okay. Hopefully that's all I need. Okay, and then let's okay, now what? I just want to try and compile this and see if things are working. So then let's when we get to this stage, we're going to break. And then let's output something. So let's like output what, that's fine. We'll do this, and then we'll just, let's do a debug print of what the very first operation is for this particular thing. So this is we want to print the current UI op, and okay, let's do this again. Okay, this struct is invalid. Why? Is it because I meant to say const this is this? No, to declare a container, do const this is equals struct. Wait, what? Okay. How do you declare an enum? This isn't what we want. Did I go past it? Am I not just using this syntax right here? Const thing equals enum, number of bits for the enum. Oh, I forgot this thing. Let's okay. Part of me just wanted to like start a count of how many times I make this error, but that's unnecessary. Okay, line 50. Expected return type expression found bracket. Is a void. 61. Expected var or const before variable declaration. This is going to be changing a lot. And likewise for these ones, we're going to be changing those a lot too. Likewise for this. Likewise for this one. And yeah, let's just move this note. Well, the question is really now actually, does zig 0 init arrays by default? And then I should just, okay, 77. Why do we need a semicolon after a switch statement? Oh, because it's not actually, it's a switch statement, but then we're still setting something. Okay. And then, okay, 42. Oh, enum field missing name. I see. I think we just need to delete all of these. Use of undeclared identifier current byte. Okay, I'm kind of happy I did try and compile this because these are a lot of mistakes. Good to clean them up now. I guess we need to define another variable called current byte. Yeah, this is a U8. We'll make this 0. Maybe we should make this undefined. Actually, unused local variable, current pixel. Yeah, we are not using that. unused function parameter. Yeah, we're not using that either. So let's just the temp stuff. Let's just set this. So why don't we say embedded QAI file 00 is equal to like 1. What do we not? Oh, pixel array. We don't want to be changing the embedded QAI file. We just want to be changing the pixel array. Okay. Okay. This is working, and the important debug info though was what? What's the current op? Oh wait, why are we not seeing it? Maybe because I need to actually call this function. Okay. So we've done this header, and now we want to do QI to pixels, and we want to pass in the embedded file. So the test image, then kind of the width and the height. Let's actually start like writing out more information for this test image. So yeah, we've got this test image. We've already defined test image pixels here, and the header. So here we want to say test test image width is equal to the test image header dot the image height. Likewise, the width is the width and the height is the height. And then we also want to say, then this should be enough to call QI to pixels. So now we've got this test image, and we need to call the width, the height, and the array itself. So the width, the height, and then the kind of the comp time array we defined. Well, the array set up at comp time. The what was it called? The test image pixels. And we need to take a pointer to this image pixels. Okay. Now let's give this a go. Use of undeclared identifier test image width. Yes. Unable to evaluate comp time expression. Why? These should be comp time. Why don't we just move them to the global scope where they will be comp time? So yeah, after we pass the header, we just immediately define these things. To do, yeah, move these. define these in a more general. Okay, still getting a comp time error. For the eye width, I'm a bit confused because in Odin this was something I could do. Like I could say, oh, okay. What I just wanted to say is we need to know this at comp time and we need to know this at comp time. So we just literally need to write in comp time here and comp time. And I should probably that's all we need at this stage. Oh, what? Really? What does it mean types are not available at runtime? Like many of them are. Oh, sorry. Yeah, types are available at comp time, but not runtime. What's going on? Yeah, varx.t equals undefined. Yeah, could be. I guess I'm still trying to just work out why is this causing an error. Like this is done at comp time, so all of these are known at comp time, and so then therefore this is known as well, and this is known as well. So okay, so if we just say this is equal to oh I see, this is of type this and equal to undefined. I think that's what I want. No. Okay, different error. 61. Likewise, this should also be undefined. Like, it's gonna take me a while to let go of the Odin syntax, you know, x double equals 1, something like this. But I like this. It's makes it more readable. Okay, 64. Okay, yeah. So this current byte index, I guess we want this to be, if the width is a U32 and the height is a U32, we probably want this to be a U64. But I can't really imagine an image that's so large that it kind of needs more than 2 to the 32 stuff, but whatever, we'll have it in here. Well, actually, if we're using this as an index, this should probably be a view size. Okay, 66. Likewise, the current pixel index is we want this to be U size as well. 72. Our switch must be able to handle all possibilities. I mean, curious that this is now causing a causing a compile error when we weren't calling this function before, we weren't getting an error. That's kind of curious a bit. Um. Okay. What possibilities are we missing? On line 74. I guess we're switching over a U. Yeah, just over like a U8. So we need to specify what else. And it should otherwise be unreachable. I am curious. Is there actually a type of like U4? Oh, there is. Oh. And we do get like a type of U2 as well. Okay. Curious. Okay, we can actually just make this have like the required number of bits then. So this is literally of type U2, and you have U1 as well. Yeah. Or not. Okay, slightly confused how we can use U4 and U2 given that I don't see those in here. But okay. So yeah, that's of type U2. Let's literally just make this U6 as well, since why not? And okay, in this case we shouldn't need to now do a nil statement for here. Oh, okay. Doing U2 is now causing this error. Given that we are allowed to use 2, I do kind of want to stick with this. Now it means we need to deal with this stuff. So I guess we're going to have to truncate this then. So, what was this again? Was it the truncate? Okay, maybe it's just honestly truncate that. And would likewise need to do something down here too. Truncate. Yeah, like when it comes to lazy evaluation and lazy analysis, I'm not totally. I certainly don't know all of those choices that the Z compiler makes. Yeah, so if I lazy, okay. Currently not in the documentation, but hopefully will be in the future. Okay, we're slowly fixing this code. I honestly didn't expect that what I had written had this many errors in it, but it's good. You know, one of the Z philosophies I think is to fix the errors at com time are better than errors at runtime. That's what we're doing now. We are saving ourselves hours of pain. So 88. Oh yeah, we're setting a pixel, so using 1 is not acceptable. So let's set it to this. Okay, hurrah. Finally compiled, and apparently the first operation should be a diff. Let's check to see if that's actually the case. So we were opening up this RRR thing, QI tests. I think maybe this is actually one that I annotated. No, I didn't. What's one that I annotated? This will be an easy way to test it. This one. Let's change this just to that then. Okay. So yeah. So apparently this one is also a diff, and indeed that was what we got. Great. Things seem to be working so far. Let's save everything. So we want to add in, what did we change in the main.zig? Doesn't matter, we'll just ignore that. qi.zig and I think that's kind of it. This is all we need to do. Continue writing AQI parser. Seem to get QI ops working. Okay, back to this. Okay, let's get rid of the temp stuff and continue. Okay, so now we've figured out what the current operation is, and so now we need to write out the corresponding pixel and do the corresponding updates. Okay, so we're gonna first have to determine if we need to hash the pixel, I think. So this will depend on the op. So if the operation is a run, we've already literally it's just repeating the previous pixel, so it has been seen before, and so there's no need to hash it. Let's write this down. We need to hash a pixel and store in the corresponding index. What did we even call it? Previously seen pixels. When the op is, I'm moving the disk down, am I? Okay, I'm still visible. Right, yeah. Okay. When the op is what? When the op is one, not already, sorry, when, it's not just the op, it's a couple of things. When one, the pixel is not already in the previously seen pixels array. And two, the op is one of, okay, there's a couple of conflicting things happening in my mind at this stage. Could this solution honestly just be as possible as hashing something, as actually kind of ignoring the ops, and instead just hashing something and then seeing if that hash, seeing if a thing is already hashed. I feel like it should be possible just from the operation to determine if we need to hash something or not. Yeah, so certainly if it's a run, we don't need to. If it's an index, we're literally looking something up, so it's been seen before, so we don't need to. Okay, instead of like saying when I need to hash a pixel, why don't we change this to when I don't need to hash a pixel? We don't need to hash when the op is one of the run, the index, I feel like we'd only be seeing this RGB and this RGBA if it wasn't already in the index. So I think these ones mean we do have to hash it. RGBA. Okay, and then what does this kind of leave? So this just leaves the diff and the luma. What do we need to do in these cases? Okay, so if it's a diff, many times when it is a diff, we will need to hash it. But it could also be the case that we have a diff and then the result is something that is already in the index. Perhaps the question then is, in the specification, if you can get to something with an index and you can get something to a diff, which one is preferred? Is there actually one that's always canonically preferred? If there's not, I would say this is some undefined behavior in the specification that is annoying me. Hopefully this has been described. Let's look at the specification again then. Is the order of this, like the order of stuff we should be going through, is it like if you have a preference of choosing these versus this, you do the earlier ones? No, because these are larger. So maybe then it's like choose the smallest possible value, smallest operation in terms of bytes, and then do it in preference. Okay, none of this seems to tell us which way to go. And this doesn't, like, maybe this is the preference to do it. Like, choose a run of the previous pixel when possible, if not an index, if not a difference, if not that. So yeah, valid encoder must not at least issue 2 or more same index. Run should be used instead. Okay. This is annoying. This feels like undefined behavior. I think we'll just have to deal with it then, and that it could be both of these. Okay. Okay, so given that the diff could be used to get something that could still actually be in an index. Okay, let's start with the index. If it's the index, there's no need to hash it again. That's fine. So it's truly only this diff operation, which is, well, it's the diff and the luma. Okay, so we can say for both diff and .luma, the specification doesn't say when encoding whether or not index should have a higher priority than e.g. As such, hashing a diff result may be redundant, but we'll choose to do so anyway. Okay, I think now I understand which ones we're gonna choose to hash or not hash. So hash this, no need to hash it. There may not need to be a need to hash it, but we could also need to hash it, so we'll just hash it anyway. Likewise with this one. Since this one is 2 bytes, there's no way this would be used if we were actually indexing it. So so actually we can put luma in here as well. Okay, this is an underlying assumption. This is the assumption that the encoder is going to always going to check if the current pixel is previously in the buffer and just index that instead. I think that's a fair assumption to make. Okay, in which case maybe that actually means that we would always actually need to hash the diff, since okay, hopefully this won't be any errors. We will do some tests, and hopefully those tests will discover any kind of errors. Okay. Let's just say here, since the op is 2 bytes, but a index op is just 1 byte. Okay. And then I'll put in diff here. Then I'll just say note, like for diff, doesn't say this could be because index should always be chosen if a pixel has been seen before, except in the case that that the run is really long. 2 consecutive index. In which case a run would be issued instead. Okay. Okay. So let's use this information to now actually do like the necessary hashes. So yeah. So let's then say do we need to have a current pixel hash? So why don't we say pixel hash is like this is a loop, so why don't we just say it's a U8 and undefined to begin with, and then we'll update this with the switch if we need to. So what is it? Let's keep all of that stuff here and then the new stuff here. Okay. So now we want to switch on the current QII op. And then in the case that it is a let's list these in the same order that we kind of have them here. So if it's a run, switch syntax question. In Odin, I can actually just list them like this, and then I would be able to define it like this. Can we do this in Zig? Where's the switch statements? Did I skip it again? No. It looks like I can. Great. Okay. So yeah, do this stuff, and then for RGBA, RGB, RGBA, and diff, we then yeah. So for the run index and Luma, there is no need to hash, so we can actually just continue on. But for these ones, we want to compute the hash. So for these, we want to say that the pixel hash is equal to the pixel hash is just equal to literally pixel hash of what? Of well, we're gonna have to figure. We're gonna have to do some decoding first. Actually, figure out what the pixel should be. Okay, we're doing this a bit too early. Okay, but it was still good to think through these possibilities. And actually defining it in this like undefined way seems feels a bit unnecessary. Like perhaps we can actually just say the pixel hash is going to equal the switch statement of this, and then for the run index and Luma, kind of who cares what it is, we kind of shouldn't be using it. So why don't we just say this is actually, it may be better if we get a. This is some micro detail I should be focusing on at this stage. This might also give me a compile error, but I haven't used this at all. We'll come back to this. Okay, back to the specification. So now, okay. So yeah, we're gonna have to like hash these things later, but at least now we know for which of these what we're gonna hash and not. But before we even hash these, we need to figure out what the pixel values are. So let's do this, and this is going to depend on the operation. So why don't we just kind of work through these in the same order that they are in the specification. So now we want to calculate the pixel values. So let's switch on the current QOI off, and if it is of a type RGB, this is one of the easiest ones to actually figure out. So now we need to just examine the next 3 bytes, create a pixel with those bytes, save it to the pixel array, and then move on. So why don't we just say the red byte is going to equal the something, and likewise we've got the blue byte, the green byte, and the blue byte. And so this is going to equal what? We need to use the current byte index and go forward by 1. So the current byte index oh, hang on. I always feel a bit wary of like increasing some like variable, like doing 2 things in one line. I don't like this at all. Let's just do these separately. So we're going to be calling this 3 times, and after the first time we want to read in this first byte, then we want to read in this one, then we want to read in the blue byte, and then we also want to increase the index 1 more. Okay, so this red byte is then going to be our embedded QOI file at that given position. So yeah, the embedded QOI file at the current byte index. And yeah, this is, we can actually, okay, I was going to say we could put this in a loop, but it's probably easier like this. This seems a bit untidy though. I'm thinking of doing something different. What if we instead just increase the byte index by 4 at the very end and just manually specify these as +1, +2, and +3. I think that would both be easier to read, and it probably wouldn't make any difference in the compiler. But it might. The compiler would probably be smart enough to realize the current byte index isn't changing otherwise. Well, okay, actually maybe not. Okay. We're going to do this differently. We'll increase this by 4, and then we'll just literally say, yeah, this is +1, this is +2. This is a lot easier to read. I like this more. Okay, and now we need to create the pixel that we want. So then we can say new pixel is going to equal pixel and then this red byte, this green byte, the blue byte, and then the current alpha value, which is where did we save this current pixel? Up here. Okay, and then it's the current pixel. Pixel index 3. Okay, we now need to write this to our array. That is, we want to say the pixel array at index, current pixel index is equal to, where are we? The pixel array at the current pixel index is equal to our new pixel. Let's now increase the, hang on a sec. This pixel array is not just of type length this, it's, we're giving this some height and width. Okay, I'm now just tempted to change the type of this array to just be a single array, like not some matrix, just a single array, simply because we will otherwise have to like figure out from the current pixel index the height and the width. Like maybe this isn't actually too annoying to do. Like it would just be 2 lines. Oh, okay. Two-Step has an amazing suggestion to clean up this code even more. Okay, so just say, okay, so we could possibly use a slice syntax to instead eliminate a lot of this, which I didn't know we could do in this case. So, so you're saying current pixel is bytes. Okay, like, I mean, if you're happy with this, I guess I'm happy with this too. Like, I feel like this is readable. Like, this communicates to anyone reading it kind of what's happening. Okay, yeah, but back to this current issue. Should we just change this to actually be a single array or a matrix? I'm kind of actually opting for an array because nothing about this entire specification cares what's like above or what's below. It's literally just what happens previously, and once we've done this decoding, we can then easily like do type conversion stuff and just say, yeah, this is just an array, but treat it like it's some matrix. I feel like we're adding unnecessary complexity by wanting the type of this to be a matrix instead of just an array. Okay, let me just add this in as a like decision of should this procedure take in a pixel array that is a matrix or a simple array. Like, I feel that in general, adding in layers of abstraction just makes things more complicated, and almost like every data type should be an array. And so I feel like that's what I should be doing here. But maybe later on in this project I will feel differently. Okay, this is gonna take, we're gonna have to now just rewrite some of this stuff, but it's okay. I think it's gonna be better. So in particular, we're now just going to have we're gonna have to tell it comp time what the number of pixels is. What am I doing? Number of pixels, and I guess this should be a U64. Okay, we're gonna have to adjust this stuff down here. So now instead of just passing in the image width and the height, we want to pass in the product of these, and we need to convert this to a U64. This is just multiplying two U32s, which, you know, in the unlikely case that the image actually has a dimension of like 2 to the power of 32 minus 1, this could cause an overflow. So I guess we should convert each of these first. How do we do this in Zig? I think we can just say as. Okay. I think we can honestly just say this is as. Treat this one as a U64, and then treat this one as a U64. Okay, and then what else? What other changes do we need to make? Hopefully that's kind of it. I don't think currently in this function we've actually used like the eye width at all. Oh, we did. Okay, we'll change this as well. Number of pixels. Okay. Hopefully that's all the changes we need. If not, the others will be revealed when we try and compile this. Okay, back to the specification. Okay, so now we've saved the new pixel to here, and we would need to hash this, but we'll do the hashing stuff later. What other things do we need to update? So we've increased the byte index by 4. We also need to increase the current pixel index by 1. So yeah, I've done that. I guess we should update the current byte as well, actually. So then why don't we say the current byte is equal to, yeah, this should be fine. The current byte is equal to the new pixel. We then set it. Oh no, I'm being really silly. The current byte is the one in the embedded file. This is not the pixel. That was unnecessary. Okay. If we're increasing the current byte index by 4 here though, should we also set the current byte, or should this actually just be something that happens? Should we just set this at the start of every loop? We do. Okay, we do. Good. Okay, so we only need to set the current byte index. Okay, so yeah. And intuitively, this is what should be happening. We're just saying each time in the QOI file, move to the next place where we want to read from, and then once we've written the pixels to the array, move up the appropriate way. Okay, this should be fine. Okay, we now need to do the RGBA option, and this should be very similar. Bug alert. When I was saying increase the current byte index by 4, this was what we needed to do here, but for the next one it's going to be 5. So this is 4, but this one is 5. And here we need to also define what the alpha value is. Let me just put the specification here. So yeah, we're currently working on this one. So the alpha byte is now +4. And then instead of using the current pixel index here, we're now just using the alpha byte. So yeah, likewise, pixel array is this thing, current pixel index is that. I kind of want to maintain what this new pixel is though. Like we'll potentially need to know it when we're hashing. Are we not saving this currently? Yeah, we should be setting the current pixel to this. So we've got this new pixel, and then we want to say the current pixel is equal to the new pixel. Yeah. Okay, set these things, yeah, increase that by 1, increase it by 5. Okay, next one, the index. Index. Okay. So then, this one is more. This is going to be more complicated, but only slightly. So now we're going to have to read what the next 6 bytes were, which we saved. We saved when we did these bits 0, 1, 2, 3, 4, 5. So we want to look up the what's it called? Look up the place where we're storing all of the running weight, the previously seen pixels. Look up a pixel in previously seen pixels. Okay, and let me just annotate for these other ones a summary of what these operations are actually doing, even though they're still pretty clear. So this is just like read a RGB with same value from the embedded file, and that's all it is. And this was just okay. Using the 6 bits of the. This house is really cold, and so I'm just going to blame the temperature for my typo mistakes when typing today. I feel like I'm not usually like this. Recordings may suggest otherwise. So okay, so we want to first cast the. We're gonna be turning this into an index, so we need to cast these 6 bits to something of size usize. So why don't we say index equals as usize bits 0, 1, 2, 3, etc. And then I think we just literally say the new pixel is the previously seen pixels is index. Okay, I lied when I said this was more complicated than the previous instructions. I think this is kind of all we need to do. So now we just say we just do the usual here. Immediately, I'm kind of wanting to start tidying this code a bit. Given that at the end of each of these operations, we're going to have to advance the pixel index by some amount, which isn't necessarily always 1, because it could be a run. And we're going to have to advance the current byte index by some amount. I kind of actually just want to factor all of this stuff out of this switch statement, and instead have this switch statement return the or set like a pixel index to advance, a current byte index to advance, and throughout the process the new pixel is set. I think this will just make the code a bit easier to think about, and it will make it shorter as well. So I think what we want to do is let's just clean it up now so that we save time when we do the next operations. So we just want to calculate the next pixel values and like the byte index and the current. Why don't we say and the pixel and the index advances and the. Okay. So we're switching all of this stuff, but throughout this process we want to say the current pixel index advance is going to be what's the type of this? This is going to be the same type that the current pixel index is, which all of these are usize. Okay. And likewise, the current the byte index, the byte index advance. Okay. So we can get rid of, we can almost get rid of this new pixel stuff. Yeah, and that, okay. All of this stuff up here, I can now say just the current pixel is equal to this thing, and yeah, we'll factor this stuff out, but we do need to set this stuff, and this stuff is now going to be the pixel index advance is this, and likewise the byte index advance is equal to these things. And yeah, we can get rid of this stuff and just say the current pixel is equal to this. Okay. And then, okay, outside of this switch statement, now we want to say the pixel array at the current pixel index is equal to the current pixel. And now we just want to increase everything with the advances. So increase this by the pixel index advance, and likewise increase the byte index by the byte index advance. So yeah, set that, set this. I want to say current pixel is equal to that one. And then what are the advances? We're advancing the index by just by 1, and we're advancing the byte index by 1 as well. I think I need to have a commas after each of these switch statements. Okay, what's the next one? Next one is the diff. So now we are going to say if we end up with a diff one, this was one of the this one is going to be harder than the previous ones, since we need to do this like offset stuff, which isn't too bad, but we need to be careful. Okay, so likewise we're going to need to use the 6 bits to compute this kind of stuff. So we want to say we're going to be doing wraparound operations, and so I think, would it make sense to convert all of these to bytes? Well, given what we saw with the pixel hash function, we were able to like coerce the types to be larger if necessary. So maybe we actually just honestly say that the difference of red here is of type U2 and is equal to the bits 1, 2, 3, 4 once we move them down by 4 and truncate them. Then so the green and the blue, we want to now shift these down by 2. But okay, question, in the Zig compiler, does shifting these bits down add in zeros at the beginning, or is it going to do some complicated like complement thing? I guess we could check this in a test, but well, I guess it doesn't matter. We're truncating it anyway, so yeah, okay. No need to worry about this. I mean, it's still a valid question, but no need to worry. And then for this one here, we don't need to actually shift it down at all, but I'll just, it's easier to read like this. The compiler will go does nothing and take it out. Okay, so now we have these. We now need to do the appropriate conversions. So now we want to say we need to subtract 2 from each of these, allowing wraparound, and then apply these to the current pixel. Okay, so we could say then the current pixel. I want to do the following. I want to say the current pixel is equal to current pixel kind of 0 minus this minus the dr minus 2. Hopefully this will work. And the difference in the green, the difference in the blue, and then just the current pixel 3. And I think that's all we need if this compiles, and that's a big if. And then what about the advance? We're advancing the index by just by 1, and we are we're not doing that. We're setting it equal to that, and then we're advancing the byte index by 1 as well. Okay. Next instruction, if this is fine. We still need to be a bit more careful since we're doing wraparound stuff. So I want these operations to potentially wrap around. This will likely give a runtime error unless we actually tell the compiler to expect this. Okay, so given that earlier, when we did multiplication that to tell it it's okay, do we do a similar thing with subtraction? Yes. Well, I kind of want to have the wrapping around with an unsigned integer though, not with something that's signed. Can cause overflow to integers. So maybe it's okay? Oh, okay, this is what we want. I think this is what we want here. It's like a U32, it's wrapping subtraction. Okay. Okay. Now I'm just wondering about order of operation stuff. If I do this, is that going to be fine? Is this going to say wrap it around with that, ignore overflow, okay, ignore overflow. I think this should be fine. Hopefully this is okay. The specification regularly assumes wrapping subtraction. Hence the wrapping subtraction. Okay. Oh, Suzette has said zeros. Have I written the bug where there's zero somewhere? Maybe it was just this stuff. Okay, I'm fine. Great, thanks. Okay. Yeah, I regularly make copy pasta errors. I've somewhat reduced them when I start writing this, but I don't always write that. Something for me to improve on. Okay, now we need to do the luma op. And this one is the hardest one. This is the one a couple of nights ago we spent quite a while working through. Let's bring up the example we worked through. And it wasn't this one. We had to look through something else. It was this 3x4 annotation. And while we're on this, let's change this to the 3x4 example. Okay. So when it came to the luma, what happened here? So okay, so yeah, so the potential zero error was referring to shifting adding zeros. Okay. Like, hey, I think I do remember seeing some like compiler bug somewhere, I don't know how long ago, referring to this kind of thing when dealing with maybe U8s or something. And so like maybe this actually, I don't know if the bug, if one, this will cause that kind of bug, and two, if it hasn't actually been fixed. In either case, we'll find out. I mean, yes, we technically don't need that, but then for readability, I think it's easier. Let's just say like this is a bug watch, because there could be something there. Okay, back to this luma example. So, or really onwards with the example. So, what did we do? Okay, yeah. So we needed to first of all convert all of treat the values in here as unsigned values, and then offset them by the appropriate amount, which was specifically subtracting from them like 32, 2 and 32, 8 and 8, based on these parts. Then once we did that, this told us the offset for the green, but we need to figure out the actual offset for the red and the blue. And then we did this by saying, take the green value and then kind of subtract or add. Why add? Hang on, why? Basically just like, the idea was just this plus this. But now I'm slightly confused because like 16 minus 2 is 18, not 14. Oh, it's just because of algebra. When you rearrange this, you get dr equals dg plus the offset. So that's why we're adding them. Okay. Okay, so let's do the first part of just even getting these things. Okay, so the first 6 bits are simple enough. We want to say diff green is equal to what should the type of this be? I feel like it makes sense to make everything in this U8, considering there'll be many calculations. The bits 0, 1, 2, 3, etc. We then need to read in the next byte. So now I can say that the I've forgotten what is the name of it. We need to look at the embedded QI file. And then we need to take the current byte index, add 1 to it, and this is going to be the DRDB byte. And then we're going to have to truncate this a bit. So we can now say that I'll call it like the DDR just to make it clear. No, that's not great. DRDB byte DRDG is going to equal. It's going to have type U4 and is going to equal what happens once we shift this by 4. Likewise, when we for the DG, we'll get that. And now, actually, like, what's the point of treating this as U4, given we're gonna have to do all of this overflow stuff anyway? Yeah, I feel like these should all actually just be U8s. So in that case, let's just AND this with 1111. There's an easy way of doing it. AND it with F0. And likewise, AND this with 0F. Okay, now we need to do the appropriate offsets. So now the offsets are, why are these constants? These are going to have to be variables, at least some of them. Now we want to say the diff green minus with wraparound 32. Okay, can I do this? This is kind of what I want to do. I just want to say minus equals 32. Is this allowed? Minus wraparound equals. Yep, that looks legit. And then for the difference between the red and the green, the wraparound is 8. And then for the difference between the blue and I'm getting these wrong. DRDG, DBDG. we also get, come on, I can type a percentage sign without looking at my keyboard. Oh, got it eventually. We're also -8 from this. And now we want to actually apply these differences. So now we want to say, we just want to add, this is the legitimate diff greet, and then we want to add, want to do some addition. So now we say, this is just honestly equal to the diff green. The dr is equal to the diff green plus the drdg, and then the difference in blue is equal to the diff green plus the drdb. Now that we've got this, we can actually work out the relative differences. I mean, we've worked out the relative differences, so now we just need to apply them in a very similar way to this. So copy pasta alert. Let's just think about this. I want to say for the current pixel 0, actually, there's there could be a I think there may be a bug with this one, in that I think these differences are meant to be positive rather than negative. Yeah, I'm pretty sure this should actually be, these ones should be pluses. Presumably this is allowed, this is an allowed operation as well. Yeah, wraparound addition, subtraction, negation, multiplication. Okay. Curious that they have separate names like that, but okay. So we should be doing something similar here. Okay. But in this case here, everything's kind of defined relative to the green. So we have, and we've already incorporated all of the offsets and everything. So this should really just be the difference in red, the difference in green, and the difference in blue. And then that's remaining the same. Okay. Not so bad, now it's all written out, but it took a while to get there. Okay, let's do the updates, the advances. So the pixel index advance is not 1, this time it's 2, because, no, this is still 1. It's the byte index advance that it has increased by 2, since we've now used 2 of these. Okay. Final op is the run. I really should be like compiling this and just seeing if it's working, but I'm going to do some massive conf thing test at the end. Okay, so yeah, so back to the run, or really to begin the run. This one is also nice and simple, thank goodness. We want to convert the run here to an index. We've kind of done this before with the index stuff. Let's just copy this. But now the run is, you have to take that to a usize. we don't need to change the current pixel. This is actually going to be the same. So now, and that shouldn't be a problem since, where do we define the current pixels again? Yeah, it should be fine. And yeah, the byte index is going to advance by 1, but the pixel index is going to advance by whatever's actually in this run. Okay, so we don't actually need this to be a usize. I think we can leave this to be a u6. And then we just want to say for, we just want to write a bunch of pixels. So we want to say while while run does not equal 0. Oh, hang on. This isn't actually going to represent the run because it starts off at 1. So we actually need to increase this by a 1. In which case, could there be overflow? I don't think so, because it's not going to be of type. It would only be overflow if it was 1, 1, 1, 1, which it couldn't be, because that would be the scenario over here. Okay. So we can actually just say 1 plus or equals 1. The run is stored. Let's put it there. Yeah. Okay. Increase that by 1, and now we want a loop. So now we want to say while the run is not equal to 0. Okay, and what's the syntax? I think this is the syntax for, in a while loop, to do something every time you come back. You want to do run minus equals 1. We just want to set the this part of the loop is slightly different from the stuff that comes outside of it, where we're setting these pixel arrays. And so I think that's fine. We can just set this pixel array twice, but we'll make sure that within this loop we do set everything. So we want to say yeah, the current the pixel array I'm thinking a bit differently. If we instead treated this run value as type usize, we can then use the run down here when we're setting the values of the pixel. Yeah, I think I want to do that actually. So then we get this run, and then I need to be careful with an off by 1 error here in this step. So say the run is actually a 1, then, okay, say the run is a 2, then we want to be setting the pixel array at 0 and at 1 to be this. So if we instead work backwards, would this work? so say the run is 2. If the run is 2, it's stored here as a 1. So we convert it, increase it to a 2. Then we're saying set the pixel array at 2 minus 1 to be this. Move it down 1, it's not yet 0. Set the pixel array to be 0 to this, set it down to 0. We've run out of the run, so we're fine. And now for the pixel advance index, we've now added in a run's worth of stuff, so push that up by 1. And then in terms of the byte advance index, this has only taken up a single byte as well. So, kind of push that up. And then, hang on. Given this line is going to be called again, we can just say we could instead actually have no. I was going to say we have a continue in here, but that's there may be some code after this we need to actually run, so we won't do a continue here. Instead, we want to say what? We want to go. Okay, the question is, what do we set here so that when this stuff runs, which we basically don't need to run, nothing will get screwed up? We could even actually have the final pixel set done by this one. So how could we do that? We could just say maybe if the run is not even equal to a 1, then decrease it. Then if this, when it gets to 1, it's going to go to here. The current pixel index hasn't changed at all. So then it will get set to the previous one, which is what we've been doing anyway. And then it's going to be advanced by the appropriate number that have already been set. And then yeah, I'm just hesitant about. I feel like maybe there's some bug I've created here. We'll see when we come to do tests and stuff. But it seems to me okay. Two-step is referring to something. Run always equals 0 after this loop. So pixel advance always equals 0 as well. Oh, that's a really nice solution. I like that a lot more. Yeah, very nice. Okay, we'll set this back to 0, and we'll just make it so that the yeah. So you're saying yeah. So basically set like the pixel advance to be 0. The byte index still needs to be 1, but you're not a solution pointing out a bug. Okay. So you're saying that or move pix advance up above the loop. Move pix advance above the loop. So you're saying move this one perhaps up above it. So okay, I'm still unclear currently like why where the bug's coming from here then. So yeah, so my understanding is we have like this stuff does do the correction of how many times we are meant to repeat a previous pixel. So then here we're saying, like kind of for each of those numbers, kind of go forwards, like the current pixel that the buffer is at should be filled in. So we want to fill in everything going from 0 to the run minus the 1. And so kind of just start at the end of that and kind of go backwards. And then once that loop is run, then say, okay, we now want to like increase it by this run amount, and then we want to increase the byte index by 1. So then in this pixel array, this is just going to repeat writing what the 0 pixel is, which, you know, okay, it's like one extra write, but presumably if the run is being called, it's going to be called a lot, so whatever. And then like increase stuff appropriately. Okay, so you're saying at the moment pixel advance is always 0. Oh, yeah, that would not be good. So why is the pixel advance currently always 0 after the loop? Oh, I see. Yeah, the run has been modified. Great. Okay, I totally see the bug. Yeah. Great. Thanks for pointing this out. Okay. Thank you. Okay, I was right to be cautious of this, and thank you for correcting me. Yeah. So. Okay, yeah, so now your solution to this bug is to say, perhaps move pix advance up above the loop. Yeah. So let's move both of these things up above the loop. And let's also just note that something weird is happening with this one as compared to the others. So we can say unlike the other ops, which only write a single pixel. This one writes a repeated number. Writes many by repeating the value. So things are a bit different. So the code is a bit different. Yeah. Okay. Yeah, great. Yeah, so now we've set those. So now when it goes to 0, that is okay. Great. Okay. And yeah, and then okay, we've done loads. Let's just let's just try getting this compiling and fixing errors, and then we'll move on to the hashing part. Oh, okay. So maybe there's still a bug. Down 2 lines, I mean. So move pix advance after assigning to run. Oh, yeah. Yep. This would be a compile error. Yeah. So we want. Hang on. We want to. You're right. Read it from the binary. Adjust it appropriately. Now set the advance. Then do that, and then do the loop. Okay. Okay. So I'll say like note. Setting this after the loop would mean that 0 mean that the run is 0 the advance is 0, which we don't want. Yeah. Okay. Okay. Hopefully this iteration is bug free. But I may have spoken too soon. Okay. Let's bring up the compiler again. So yeah, so we want to do z run qi.c. Okay. Yeah, we do need to set each of these. Expected comma after initializer. Yep, these are pixels. Expected comma after prom. Okay, yeah. Expected expression found in valid bytes. Oh, why is this giving an error? Oh, there's meant to be an S. What? Why is this expecting some semicolon? This looks like a semicolon to me. Did I get? No. Okay, I had one too many parentheses. Okay. Use of undeclared identifier index. Yes, because we want to set this. I'm so bad at just like forgetting to say, yeah, I'm declaring a new variable compiler. Maybe I should start an index counter for how many times I get a compiler fail because of this. Wait, I kind of did up here. Okay, maybe what am I doing wrong? Oh, yeah. This should be D difference blue, difference green. Okay. 155. Like I kind of knew when I was doing this there was going to be an error. The compiler would catch it, and it did. Use of undeclared identifier run. Sure. 225. Expected type blah found blah. So yeah, it expected to find this is the 3x4 image. So, and just a reminder of what this looks like. Wait, it's QI tests. 3x4. Wait, what? Okay. Magic K 3x4 png 3x4.qi. What? Okay, this is already like, let's just like do this tangent from the compiler. Why can't I see this image file that I'm sure a couple of nights ago we created and were able to see perfectly fine? Friend view anything in here, please. Just open anything. Okay. So it was the one that's meant to be this, but why on earth is? Okay, I guess it can actually open this in here. Anyway, whatever. The point is it was this one. So yeah, so this was of type, it was expecting just the overall number of pixels in the array, which is 12, but instead it found this stuff. So I guess there was actually something we didn't fix initially in test image pixels. All right, yeah. So here we want to just say this is of type the width times the height. Okay. No compile. Back to compiling, please. Zig build. Okay, maybe it's working. Okay. Yeah, and oh, I'm being silly. We are nearly at the point where we can start using this in the app, but we're not there yet. Okay. I was like, that's too good to be true. Like, there has to be more errors. 95. usize does not support indexing. What? I thought like the index type in Zig was usize. What? If I do like U64, like I could have sworn. This indicates I don't actually know about what the type of indices in Zig is. Like, what are they? It's also a bit cold. Let me. What do we do about this? Okay. Two-step says you're trying to index a usize at the end of that line. Yeah, so I'm saying current pixel index. Oh yeah, totally. Yeah, I would have used the current. Yeah, the point is this is meant to be a byte, but we're instead trying to index the usize, which is very silly. So yeah, so what should this be? So this should be instead. We just want the alpha value of the current pixel. So we just want to say current pixel, then the alpha value, which is 3. 96. Okay, so maybe the data type of indices in Zig is usize. Okay. 96. Cannot assign to constant. Oh, did I really do? Yeah, both of these should be variables. Okay, it's compiling, but there are errors. There's a runtime error. Integer overflow, because we didn't do overflow operations there. So I want to do overflow and overflow. But what's the type of these going to be? These at this stage, these should be bytes. Yeah, we made this to be bytes. Just to make it clear, especially to me in the future when I'm reading this code. Let's make all of this obvious. Okay, let's even do that, even though it's unnecessary. Okay, cool, and it seems to be working. Well, it seems to be compiling. Let's what's a simple way we could test all of this functionality we've just written to see if it is kind of working? Probably the best way is actually just writing the hash stuff and then literally looking at the value of the pixels. But we can do a slight approximation to that. How about we where does this loop start again? It starts here. What's the Emacs command to jump to like the next parentheses? I need to look this up. Point is that the loop ends here. Even at this stage, we can print out what the pixel stuff should be. Oh, okay. So maybe I actually made another error that just caught. So, if I go, to DG, I think this part here. So you're saying it seems like it should be shift by 4 instead of. Yes, you are totally correct. Yeah, this is. Oh, wait, hang on. So the F here is just. Okay, let's see. Where's the specification? Yeah, so we've got these two things here, and so yeah, in this part here I was just saying, yeah, no, yeah, you are right. We have selected these ones, but we haven't yet moved them down appropriately. So yeah, so this really should be yeah, this really should be 4. And then for this one here, we do want to, this one we do want to do that. Okay. And this is again assuming that when we shift things down, they get filled up with zeros. Should be like left filled with zeros. Thank you again for catching this error. Okay. Okay. So yeah, let's print out what like the first couple of, or at least what the pixels are so far. Actually, we can just print out a running, each time we go through this loop, we can just print out what the value of the pixel is, and it will eventually break because we haven't yet done the hashing, but it will give us at least an indication of if we are getting the appropriate number of like reds here, etc. This will also be helpful when we do the hashing stuff. Okay, so let's just add in the debug print here then. Yeah, print out the next pixel. So we want to now say a dprint. Make this any the current pixel. Okay. Are these values, are the first of these what we expected? Yeah, we expect a red, then we expect the run of the red, which is the second line. Then we get the 0 pixel, good. Then we get something random because we haven't done the hash, and then other stuff. But that looks okay so far. Actually, things are, oh wait, I'm a bit concerned. Why are we not seeing a red after the 0 pixel? Again, like, I guess, okay. Because the hashing is not working, we wouldn't expect to see a 0 after the 0 pixel. But I would expect to see another 0 pixel after the 0 pixel. Because this would say, I'm pretty sure in this example, we had to, let's load it up again. So yeah, we got, actually, it starts off like this. Wait. Not even sure what's happening with this annotation. But, we're meant to start off with 0, 0, 0 anyway. So we did, yeah, so we get the red. Oh, something's not great though. Why are these a 0 instead of 255? Okay, the specification does actually start off with 255. Okay, that's why the 255 is here. Let's adjust this. Starts off with 255. So yeah, we then expect to see the red, and then the red, but it's repeated twice, so we only see it once here. We then end up with this blank one, good. And then hashing happens and this, but because the hashing has failed, we get this instead. Yeah, and then we kind of get like dark gray and the white, that all the hashing has failed, so whatever. Okay. This still seems to be okay. So let's save what we've done so far. So we'll save the QOI as well as the this annotation we just adjusted. We do it both of what? Why are we not saving this one? Is this like in the git ignore? No. What's happening? I don't understand. Oh, I guess because we haven't modified it. Okay. Okay, yeah, wrote out, did most of the decoding for the did most of the decoding ops. Still need to write hash stuff. Okay, so then let's get on with this hash stuff. Okay, so yeah, so two-step says 170 is in hex AA, which means unidentified in debug builds. Oh, that's really useful to know. Okay, didn't know Zig had that functionality, but now we do. Cool. I feel like I should write that somewhere. Where should we write this? Because this will be good for me to remember as well. Let's just put it here. Anyway, it's fine. No. In Zig debug builds is bytes that have been like stack memory on the stack that. Okay, what if I say like static memory? Static memory that has not been initialized. How do I spell it? Initialized is filled with 0xAA. Okay, this is good to know. Okay, so down to the hashing stuff. Like we're so close. So yeah, any bytes that are set to undefined are init to 0xAA. Oh, okay. So not uninitialized, but rather set to undefined. Yeah. Filled with those. Yeah, I wasn't. I clearly wasn't aware of this. What's Oh, here it is. I see. Yeah, in debug mode, Zig writes 0xAA bytes to undefined memory. This is to catch bugs early, like we just did, and to help detect use of undefined memory in a debugger. Oh, this is even just like help detecting use of undefined memory in a debugger. This is like, why don't all languages do this? This is great. great Zig design. Okay. However, this behavior is only an implementation feature, not a language semantic, so is not guaranteed to be observable in code. Sure. Okay. Okay. Oh, we're getting close to 2, so. Oh. Board games at 2:15. Okay, I think we can do this in like 10 minutes. If not, we'll pick it up later on today. So now we need to hash. So now we need to well, we did this here earlier. So now we're saying the pixel hash is undefined, and if we did a run index or Luma, we don't. Wait, no. For the Luma, we do need to. What did we decide? Okay, we don't need to hash when the OP is one of run index or Luma, right? Since the op is 2 bytes, but the index is just 1. Wait, hang on. Doesn't this mean actually that we would need to hash the Luma? Since we'd only be defining it like this if it hadn't already, like, if it had already been seen before, index would have been used. But the fact that it's Luma means that it is new. So I feel like we actually do need to hash this. Okay. So yeah, do nothing in these cases, and then in these cases we want to just say, well, we want to say the pixel hash is equal to pixel hash current pixel value, and then we just need to set in the array what that hash is. So we want to now say previously seen pixels at the pixel. Oh, we're going to have to do like a, we should do an assert to just make sure that the pixel hash honestly is between 0 and 64. Okay, I'm outputting this to be U8, but we could actually change this to be a U6. This would make me feel a lot better. Okay. Now there won't be any out of bounds errors. But we also need to convert it to a usize. As usize. And we kind of want to truncate this. Truncate. Okay. So we do that, and then we want to set this equal to the current pixel. Okay. Kind of like a moment of truth, I guess. Sig run.qi. No. Sig run qi.c. 195. Yeah, people are already messaging me regarding board games, but we're so close. We must get this working. Board games can wait. 195. Expected var or constant before this, yeah. Well, freely we're updating the hash each time. Well, of course we will do it. Truncate must have a known result type. But I'm returning it as a U6. But okay. I guess it's an intrinsic, so it needs this for comp time. what's happening. Evaluate that, then do it mod 60. Oh, actually, there's no need to do this mod 64 here because this is literally what the truncate is doing. So that's fine. Uh, 195. Local variable shadows declaration of pixel hash. Yeah, okay. Let's just call this hash. We are nearly there. We are close. Expected one argument, found two. Oh, truncate didn't want that? Huh? Whatever, let's just say the hash is equal to the hash is a U6, which is equal to this. Now it knows what the type is, and then we're just returning hash. Okay, error. Where? Integer overflow in. Oh, okay. Yes, since we should be adding that with that. Another overflow. No, we've now got an index out of bounds. Okay, this is not good. What? Why does it think the index is 170 when we truncated this to U6? What? Okay, two-step is saying, by the way, as usize hash isn't necessary, U6 can coerce to usize. Oh, that's good. Okay. Maybe this will fix the runtime error. Nope. Okay, why is it thinking something is of index 170? When this hash is itself 6 bits, and therefore is at most 2 to the power of 6, and last time I checked, 2 to the power of 6 was 64, right? Like, 2, 3, 4, 5, 6. Why is it saying this is the index is 170? Like the format is that it's meant to be 64. Must be a dot run or a dot index. But I guess, like, what does that mean? Because I thought from this compiler output, this line especially with this dash here is saying that it's saying like the hash here is equal to 170, and What is this previously seen pixels array? I am saying it's 64. Move assignment into hashes undefined. Move assignment into switch prom. That would explain it. Indeed. Okay, so oh yeah. That's right. This makes sense. Okay. Thank you again. Oh no. The errors don't end. What's this one? Integer overflow. Oh. Okay, I somehow when I changed that one, I didn't catch the other one either. Okay. Hopefully okay, let's just check. Is every operation in this line now an overflow operation? Yes, 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 yes. Okay, hopefully that's the last of those errors. Okay, this looks promising. Let's check. So yeah, the code begins with that, and then we have a red. And then okay, let's just, we have a red again. And then because it's a run, this is repeated, but in our debug we only print it out once. Then it's the 0. Image. Where is it? I should just keep it to it. IView QI tests 3x4. And for whatever reason it says I can't do that, but it can still somehow load it again now. Interesting app. Red. Red because of the diff, red because of the run, blank, red because of the index. Then we had like the one that looks like it's blank, but it's actually like dark. I really like a type of black, but not the 0001. Then it goes to white, great. Then it goes to green, great. Then it goes for a run for green, great. Then we have the gray, the red, great. Yes, this looks like it's working. Amazing. Okay. Yeah, I'm gonna call it here for the day. Let's just save everything. Seem to have got decoding working. Okay. And then push this. And thanks so much again, Two-Step, for much of the carrying, especially when it came to the debugging, or for that matter, picking up bugs before we needed to debug them. Your help is always extremely appreciated. But yeah, okay, I'm gonna say bye now and head off and play some board games with friends. I have some Catan expansions that I will be playing for the first time with them. Enjoy the rest of the weekend, everyone who is watching. And okay, hopefully I can come on later tonight and start using this QI decoder that we've written in the app. But we'll see. Like, I'm already very satisfied with what we did today. This isn't the first time I've written any kind of image format decoder. I don't intend to do like PNG or JPEG ever. I feel like this will be enough for games. But very satisfying nonetheless. Okay, take care everyone. Bye.